Most students see an acceleration equation and freeze up. But what if I told you that finding velocity and displacement is just a simple game? Today, I am going to show you the step-by-step calculus secret to moving from acceleration to displacement. Let's dive in. All right, look at part A. We are given acceleration, a equals 12t minus 2, and we need velocity. To get there, we have to integrate. Let's integrate the function 12t minus 2. For the first term, 12t becomes 6t squared. As for the constant negative 2, it becomes negative 2t. So the integral of 12t minus 2, dt is 6t squared minus 2t plus c. Now we have to find the value of c. We are given that at t equals 0, v equals 3. Let's substitute the given values into the function v equals 6, t squared minus 2, t plus c. So 3 equals 6 times 0, squared minus 2 times 0, plus c. Therefore, c equals 3. For part A, the answer would be v equals 6t squared minus 2t plus 3. Now for part B. To find displacement, we integrate our new velocity equation, v equals 6t squared minus 2t plus 3. For the first term, 6t squared, we use the power rule to integrate, so it becomes 2t cubed. For the second term, negative 2t, after using the power rule, it becomes negative t squared. For the last term, which is a constant, 3, we also use the power rule, and it becomes 3t. So the integral of 6t squared minus 2t plus 3 is 2t cubed minus t squared plus 3t plus c. Our goal now is to find our second value for c. We were given in the problem that t equals 0 and s equals 1. Let's substitute the given into our new function, s equals 2, t cubed minus t squared plus 3t plus c. So 1 equal 2 times 0 cubed minus 0 squared plus 3 times 0 plus c. Therefore, c equals 1. So our answer for part B is s equal 2t cubed minus t squared plus 3t plus 1. And just like that, we have filled in all the blanks. Remember the flow, acceleration, then velocity, then displacement. Just integrate and solve for c every time. If this breakdown made the problem easier, hit that subscribe and like buttons. Want to see more kinematics or maybe some derivatives next? Let me know in the comment below. See you in the next one.